Please stop me if any problem in the explanation. Okay, if you are not understood at any point, please stop me. Hope you understood this. Why I have written all these paths ranges, because when we go for LHS calculations, these ranges will help us. Okay, directly we can take from this. So for path 1, 2, 3, 4, I have written all R's same. Phi angle will change according to which path you are considering. Okay, let me just quickly recall. For path 1, phi is changing, z is the same. For path 2, z is changing, phi is same. For path 3, z is the same, phi is changing but in reverse direction. Okay, pi by 2 से pi by 4 होगा. And for path 4, z is changing from 1.5 to 1 reverse direction, but angle phi is same. So those things at one place I have written. Now talking about the LHS, in a very small, I have written this. This is our LHS, line integral of Stokes theorem. We have to calculate this for 4 different parts. Okay, so let us start this. First integration I have calculated. See, h into dl. H is given in this way. What is a dl? dl is r d phi a phi. So how I have got that? This is the cylindrical coordinate system dl. I have given you this list of dl for cylindrical, spherical and rectangular while we were dealing with potential and energy concept. Okay. So in a phi direction, it is r d phi a phi. Obviously for the dot product to exist should be a phi. Now you can see for the first path, यहाँ पर variable क्या है? Phi है. Okay, so that's why it is phi. You can observe first path में we have written at one place what is the phi range, pi by 4 to pi by 2. So in short I have written that pi by 4 to pi by 2. Okay, and phi is the variable. Obviously r and z are considered constants, so I have taken that outside. R square and one more r is there, so it is r cube. You have z plus 1, so all these are outside the integration. You are left with sine phi and d phi. What is a phi dot a phi? It is 1. Okay, so आपको सिर्फ इतना integration calculate करना है. Sine phi d phi. What is the integration of sine? Which is a minus cos. So I have written minus cos. I have applied the integration. Cos of pi by 2 will be 0. Cos of pi by 4 is 1 by root 2. Cos 45 degrees, 1 by root 2. So this is actually, this much is the answer. But for first path, r and z values are known to us. You can verify at one place we have written. R is 2 for first path, z is 1. So you can substitute these values. Where is it? Here. R equals to 2, z equals to 1. So let me substitute these things. So integration of HDL will be first value, R is 2, 2 cube, Z is 1, 1 plus 1, 2, and 1 by root 2. There is a negative sign here as well as the outside. You can see because it is minus cos. Hence, minus into minus plus. So you will get the value if you substitute and calculate the values. Okay, 2 raised to 5, 32 divided by root 2, you will get 22.627. As I said, this is your Ampere's law, which is in equal to I. So it is in amperes. First path ka line integral itna answer hai. Okay. Now let us see the second path. Check the second path. What is the variable in the second path? You have r, you have a phi, and z is changing. Okay, but let us see the formula for the second path. It is, this will not change, right? H is given to you as it is. I'm taking this h dot dl. Dl is r d phi a phi, right? So according to this, d phi is the variable according to what our consideration, h dot dl. But what is a phi for second path? We have written here, phi is not changing. Phi is pi by 2 only. आप path में travel कर रहे हो, second path, you are moving from here to here. Pi by 2 is same. It is not changing. So for the second path, when you go for integration, the answer is 0 because there is no change in the phi. Okay. Now moving to the third integration. Third integration is again h dot dl. dl is r. I think there is a mistake I did. It's not the dr. Okay. Scratch this, please. It is r d phi. Right. Check the formula. It is r into d phi. In hurry, I have written that. Please don't use this. It is r d phi in a phi direction. So for third path, check what is the angle variation phi. We have listed here. For third path, no doubt I have written in this way, pi by 4 and pi by 2. But if I see the path, direction is reverse for path 3. We are moving in this direction. So pi by 2 to pi by 4, I have to reverse the limits for third path. So for third path, it is not pi by 4 to pi by 2, it is reverse. Pi by 2 से pi by 4 लेना होगा आपको, okay? Then 2r square into r is r cube, 2r cube, z plus 1 is outside. Again, sin phi d phi, which is cos. यहाँ पर limits exchange हो जाएंगे. And for third path, we have listed what is r and z. Already at one place we have listed. For third path, r is 2 for all paths. Z is 1.5. So substituting these values, what answer we get? R is 2, Z is 1.5. I have calculated in this. Substitute R is 2, Z is 1.5. So it is 2.5. And a minus you have. So minus I have kept it. Cos 1 by cos of pi by 4 is 1 by root 2. Cos pi by 2 is 0. So plus. So यहाँ पे आपको आंसर नेगेटिव आएगा. Minus, calculate it, you will get 28.28 amperes. Third path. Now talking about the fourth path, you can quickly tell me what will be the integration. This we have calculated, we have got some value. For second, angle was constant, line integral was 0. For third, we got some negative value. Okay. Now for fourth path, again you can see angle constant है, वो vary नहीं हो रहा है, just like the second path. Here pi by 2 it was constant throughout the path. Here pi by 4 is constant throughout the path. So because of which, when I go for fourth line integral, I've written here in short, it is for, sorry again, this should not come. For fourth line integral, angle is constant, hence the integration is 0. So only two we have calculated. Finally, LHS of the Stokes theorem is adding all four. उसमें से दो आंसर 0 हैं, एक प्लस है, एक माइनस है. We have got the LHS of Stokes theorem minus 5.6. Okay. So जो आप RHS calculate करोगे, it has to be this much only. Okay, if you are verifying. Now verification. So what is Stokes theorem equation? RHS. Surface integral of del cross H. So we have to find it del cross H in cylindrical coordinates. Curl equation आपको cylindrical coordinates में पता होना चाहिए. I have written 1 by R, AR. There is one extra term R here. A phi AZ, dou by dou R, dou by dou phi, dou by dou Z. HR, R into H phi, HZ. Okay. So I've substituted that for the simplicity, differentiation easy hone ke liye I've expanded this. It is both same. Now further, I'm not going to explain you how to find this determinant. Please verify this. I have got the answer as these two terms. I have got AR direction and AZ direction. A5 I did not get. So please verify this. Once we get this del cross, what about the surface integral? I have to take two lines. Okay. Del cross H, जो भी आपका आंसर आया है, that with this. Tell me, if you have a cylinder, you're taking the surface, the path is on the surface. इस surface के लिए surface vector का direction क्या होगा? Surface vector direction, because earlier it was given in the question. Assume that rectangular, जो हमने loop का problem किया था, there it was mentioned. Assume positive AZ direction. But here let us see. अगर आप cylindrical surface का एक surface के ऊपर एक small area ले रहे हो, इस surface area का vector क्या होगा? It will be perpendicular to this surface, which is AR direction, okay? Radial direction होगा. Because of which, जो भी आप DS ले रहे हो, this DS I have to consider in R direction. So again, in cylindrical coordinates system, we have got DS of R, DS of phi, and DS of Z. So out of these three, we have to consider DSR, okay? Not these two, because we can identify surface vector का direction perpendicular to the area होता है. That's why it is AR. You can see a DSR का value क्या है? R d phi dz. So taking that, you can see we have got del cross H, AR component and AZ component. It is here, okay? Del cross H. It is now having the dot product with AR. So when I take this AR dot AR, I have not substituted, okay? AR dot AR 1. But when I substitute second, the A plus AZ dot AR, ये second term vanish हो जाएगा. That's why in the surface integration, only first term I have kept. Minus 2R square sine phi AR and R d phi dz AR. So AR dot AR is 1. Phi and Z are the variables. Phi range is given to you in the question. Pi by 4 से pi by 2 है. Z का range is given to you 1 to 1.5. So substitute the limits, substitute the integration limits, and go for separate calculation of the integrations. Please verify your answers. Obviously, you should get minus 5.65. LHS also we have got the same. Minus 5.66 we have got. When you calculate this, you should get the same answer. That is the verification. Line integral and surface integral we have converted in Stokes theorem.